All right, so let's discuss the final question. By the way, there's a small typo here. This should be question 5, not question 7. So what we're going to do is we're going to look at the actual LiDAR and look at the data being published by LiDAR, right? So let me stop my video. All right, so hi guys, this is LiDAR. This is actually quite a cheap 2D LiDAR. Most LiDARs are really expensive, especially 3D LiDARs are really expensive. And you can even get like really expensive 2D LiDARs that have a lot of range and a lot of resolution. But this is typically quite a cheap LiDAR called RP LiDAR. You can get one of these for I think like $300-400. Again, that's like the cheapest, roughly the cheapest you can get with decent quality. So you can see here that there is a you can see here that there is a projector that projects the laser point, and then you have a receiver that gets the signal back, and that's how it really measures the time of flight for the depth calculation, right? So what you do is you can set up a ROS package just like you set up the USB cam package. You can set up a package for the LiDAR, right? And then if I plug it into my computer, you can see that it starts rotating, right? So there's a mechanical motor in this that starts to rotate and starts scanning the environment. Okay, so that's basically how a LiDAR works. Since we can't really physically show you guys and get you guys to play around with this, what I've done is I've uploaded a ROS bag, kind of like last time with the RGB images, to your project files, right? So what you can do is you can play the ROS bag and kind of look at the data coming from it and get an idea of what the LiDAR information looks like, right? So I've given you guys a ROS bag. So at this point, you should be able to play ROS bags, right? So what I'm going to do is you can try it along with me. You start a ROSCO first, right? And then say ROS bag play and give the name of the ROS bag. And I'm going to give it a -L argument so it loops so that we can actually look at the data. And then I'm going to run RViz, right? So I say ROS run. Hold on. I'll just move this to the side. Right, so if I run ROS run RViz, I should get RViz pop up, and I'm going to select one of the frames. So I'm going to select the base. I'm going to select the laser frame, and what I'm going to do is I'm going to add a laser scan topic, right? And then I'm going to select the topic here as scan. And now I'm getting, so what's happening here is the robot is turning around in the same location. And this is what I explained before, right? Everything is from the robot's perspective. So it's as if the environment is rotating and not the robot, right? So you can see here, obviously this is some sort of wall, right? And we have the robot moving around in this environment, right? But since you're looking at it from the robot's perspective, it's as if the environment is what's moving, not the robot, right? So yeah, you can play around with this ROS bag I've provided. Just run it, look at what the scan looks like, get a feel for it, right? load it onto MATLAB, play around with this stuff, and soon when you start your projects, you'll be dealing with this kind of data coming instead of a real robot coming from a simulated environment, right? Speaking of which, I will upload a document by either today or tomorrow about setting up those simulations. And you will probably need to start your projects, I think, by next week or something. But I suggest once the document is up, spend some time setting up those simulations. So I'll provide a simulation for Fetch and Turtlebot. Like I said, I couldn't find an easy to set up simulation for the DoBot. So what you can do is once that document is up, try to set it up yourself, right? Try to set up both by yourselves and see which one you find easier to work with before you start your projects, right? Especially if you're see which simulations run smoothly on your computer, play around with them a bit, and see which one you would like to kind of invest the next half of your semester in, right? So spend this week setting up those simulations to get a feel for what kind of project you'd want to, out of the project list, what kind of project you'd want to kind of invest your time in. All right. So that's my advice. I will upload today's videos and last week's videos by tonight, and also hopefully the documentation for setting up the simulations by tonight, latest tomorrow. And if someone finds a really good DoBot simulation, maybe we can include that as well. But if you can, please send us that information by tonight. That'd be awesome. All right, thanks guys. I will see you next week. Thanks for sticking around. Stay safe, and if you have any questions, I'll be continuing the class for the next half an hour. So if you have any questions with ROS, setting up ROS or whatever, feel free to ask me now. All right, take care guys. Bye.